All right, so we're going to look at Chapter 1, which is really just full of a bunch of statistical terms. And so as you're learning these, rather than try to memorize a whole bunch of definitions, it would be best if you kind of looked at the homework and the quiz kind of along with this, because it's going to ask you questions where you have to use the word, not just, come up with a strict memorization of the definition. So the first thing we're going to look at is, what is statistics? So the subject, statistics, is the study of procedures for collecting, describing, and drawing conclusions from data. The drawing conclusions part is important. So we're not just going to, collect numbers and pieces of data. We're actually going to do something with them. So when we say we're studying statistics, that's what we're studying. Collecting of data and also making judgments based on that data. There are two kind of groups of subjects that you can have in a statistical experiment. The first one is a population. And so a population is an entire collection of individuals. A sample, on the other hand, is a subset of that population, so a smaller set. And remember, a lot of times we think about a population as meaning, or individuals as meaning people, but it can be anything. But a lot of times we will be talking about people or human beings, but it can be measurements, it can be temperatures, it could be anything that we could observe. So a subset of a population containing the individuals that are actually observed. So the difference here is a population would be that you look at all the individuals in a group, and a sample would be a smaller subset of that group. Okay. So when we talk about taking a sample, I think we can agree that looking at a smaller group of people or objects is easier than looking at a big group. Okay, kind of like in an election year when they're trying to figure out on election night who probably won a certain election. They don't ask everybody who they voted for. That takes time, and especially the last election takes weeks, right? But they take a sample or a smaller group and find out how much they voted, or not how much, or how many people voted for each candidate, and then they usually kind of make their guesses based on that. So it becomes important to talk about how we draw a sample. So the first type of sample, the type of sample we're actually always striving for, is what we call a simple random sample. And that is just a subset that is chosen by any method where each item is equally likely of being chosen than another item. So this is the standard that we're really striving for when we pick a sample. We want the sample to be as random as possible. Okay. Sometimes that's not always feasible though. Okay. So an example of a simple random sample might be something like this. Let's say that I need, at the college, I need 10 random students to fill out a survey. And let's say that I don't really want to give preference to any group of student. I just want to literally make sure that it's random. And so one way to make it random would be I could use a computer number generator. Which basically chooses random numbers from 1 to 200, where each number represents one of my 200 students. So So notice I don't even take anything into account other than the number that represents them. So that way I could be sure that I'm really getting a random 10 students. I'm not going off of their name. I'm not going off of what class they're in. I'm not going off of anything other than that. So truly each student is equally likely to be chosen. There's no judgment call whatsoever. Okay. All right, but when a simple random sample is not possible, or maybe when it's just not feasible, there are some other types of samples that we can have. Oftentimes people will go for this type of sample, and the name probably implies why they might do that. A sample of convenience is not a great method, but it is a sample that is not drawn by a well-defined method. Okay, so just like the name implies, I just kind of pick whoever's convenient for me. And so the big problem with this type of sample is the sample may differ from the population, and that's a problem. If I'm going to do statistics based on a smaller group of a bigger overall group, then that small group needs to represent that bigger group well, and that's kind of the problem. Okay, so if I just walked around and picked the 10 people that were in the math building that day and gave them the survey, that wouldn't be a random sample, right? Because people that were taking math classes, people that were math majors would be more likely to be chosen than someone else. So each student would not be equally likely, right? In fact, a student who's not taking a math class would have almost no chance of being chosen for my survey. But it is convenient, right? That's why it's called a sample of convenience. So I like to think of the sample of convenience as you kind of just take the things or items or people around you and you use those for your study. So a third type of sample draw can be a voluntary response sample. Voluntary meaning someone has to choose to do it. So basically only people who want to respond do. And there's problems with this too. This is not reliable. Since people with strong opinions one way or the other typically will respond more so than someone without strong opinions. So a great way to describe this is, at the end of the semester, you all review the classes that you take, and you fill out a course evaluation, which I do read all of those. And typically, the reason those are sometimes unreliable is because they're voluntary. People who are kind of in the middle, who don't have a strong opinion one way or the other, tend not to respond. And then people who are either really, really happy with the progress or really, really not are the ones that tend to respond more often than others. And actually, because we live in such a negative society, really people more with negative experiences tend to respond. So I don't know if you've ever tried to read like a Yelp review for like a restaurant or something. Those are often skewed negatively because a lot of people won't write a review on a restaurant they love, but they will write a review on a restaurant they're unhappy about. Okay. So I asked you to go to the office and get this from Coileen. So I want to look at this handout here. We're going to take some of the notes on here, and I actually want you to include this in your notes. So I wanted everyone to kind of look at this and look how the people are chosen in these different groups. So before I tell you which one's which, Each little figure and the color of their suit is significant. So that's actually what we're looking at here. So notice the people with boxes around them are the ones being chosen. Let's say we have a survey. They're the ones being chosen to answer the questions on our survey. So notice in the first figure, there really doesn't seem to be a system, right? It seems to be pretty random, right? Just people are being chosen with, not only are they lined up randomly, but they're being chosen randomly. So this is what I would call a good representation of a truly random sample. So maybe they're going to survey these people and they don't want to survey all of them, so they're just going to choose kind of a select few to survey. It looks like each person has an equal chance of being chosen. It looks like it's truly random. Okay, so I would say the first one looks random, okay? But if you look, the second one doesn't look so random, okay? In fact, it looks like the people are set out randomly, right? It looks like the color of their suit is kind of spread around evenly, but it looks like we're taking like every third person. So we're taking the second person and then every third person after that. So this is a fourth type of sampling called systematic sampling. And in systematic sampling, basically the population items are numbered. And then every K item is chosen. And K can be any whole number. So some examples of this, you might have like a manufacturing company that wants to check to see if their parts are being made properly, but they don't have time to check thousands and thousands of parts. So they just decide that they're going to check every 50th one and see if there's any defects. So then in that case, K would be 50. Okay, so anytime you're doing like every K numbered item, that's called systematic sampling. Okay. So let's look at the third and fourth pictures here kind of together. Notice that in both of these, people are first separated out by the color of their jacket, right? But then notice how it is that we're choosing people. So if you look at this third one here, we're separating them out by their jacket color or by their suit color, and then we're taking 2 people from every subgroup. But notice like we're switching out which 2 we take, right? So the 2 we take from each subgroup is kind of random, but the grouping of them by color isn't so random. So this is what we call stratified sampling. And so this is where the population or the bigger group is divided into groups called strata. And then random samples are chosen from each group. Note that in this example, we took 2 items from every little strata or every little subgroup, but you don't have to do it that way perfectly. So I've seen some of this actually quite often where maybe you want to get your employees' opinion on something and you want to make sure that you take an equal account for the men's opinions versus the women's opinions. So you would take, 15 men and 15 women to make sure that you have kind of a diversified list of opinions. Okay, so that's one example of something that we could do in stratified sampling. And then notice that the last one, the people are still grouped by the color of their jackets, right, or the color of their suits. But notice full groups are being chosen. So this would be like where you have populations divided into groups again. But these groups in this type of method are called clusters. Notice it's called cluster sampling. Okay, so I want to talk about the difference between these two since they are kind of similar. Notice we grouped them together. So maybe there was a survey at your high school and we wanted to take opinions from a big group of people. Okay, so maybe we would say like, I want to take 2 to 3 people from every classroom in second period and ask their opinion on some school related item, right? So if I took 2 to 3 from every classroom, that would be stratified. Cluster, on the other hand, would be like, I'm going to pick 2 or 3 classrooms, and I'm going to ask everybody from those 2 or 3 random classrooms whatever my survey question is. Okay, so that's the difference. Stratified is where you take a few items from each subgroup. Cluster is where you pick a couple random subgroups and you take them all. Okay. So the best way for you to get these into your brain is to practice the homework and the quiz questions based on these. So there'll be some questions where it's like, here's a scenario and you say what kind of sampling it is. So that's going to be where you really kind of are able to show that you understand what it is that all of these different types of sampling are. Okay, so remember the only one that's really truly random is this one. Okay, is the one where it's just everyone has an equally likelihood of being chosen, but the other methods have their place also. Okay, so what I'm going to do here is I'm going to say, hey, we discussed the handout here, and then in your notes you can just put that page behind, or you can tape it in, or however you want to do it. I don't know how y'all are keeping your notebooks this semester. Okay, so notice the study of procedures and collecting and describing and drawing conclusions. That was the first definition we talked about, was statistics with an S on it. But if you're talking just about a statistic, as in, have you ever heard someone say, I don't want to become a statistic? Okay, and when they say something like that, they don't mean they don't want to become a course called statistics, right? When they say they don't want to become a statistic, the word statistic without an S on it can describe a number. But what you might not know is that a statistic is actually a number that describes a sample. Whereas a parameter is a number that describes a population. So in other words, if you're describing the big group, the entire group of items, then it's a parameter. If it's a number describing a smaller group of individuals, then it's a parameter. Okay, so I like to think of it like this. Statistic and sample both start with S. Parameter and P both start with P. Okay, so you can kind of remember those. So let's look at an example problem where you have to pick out the difference between these. So I want to keep this kind of brief, but I want you to tell me whether you think these scenarios represent a statistic or a parameter. Okay, so the first one is this statement. 57% of the teachers at the training were female. And then skip a space so we can actually answer that question. And then part B, let's say in a sample of 100 teachers, 57% were female. Notice both of these examples discuss a number, discuss the number 57%. Okay, but so it really matters about what group of people you're describing here. Let me move my camera over here. It's kind of in an awkward angle. Okay, so notice this one is 57% of the teachers at the training. Notice it doesn't mention a smaller group. It just acts like it's all of the ones that were at the training. So this would be a parameter. Because it describes the entire population of teachers at the training. Okay, notice this one mentions the term sample. We have a sample of 100 teachers, so this would be a statistic because it describes a sample. Okay, so notice the same exact number can actually be two different terms, right? If it's describing the whole group, it's considered a population. If it's describing just a smaller subgroup, then it's considered a statistic. Okay, so we also can have different types of data. So the two types of data you can have are qualitative or quantitative. And I feel like you probably have went over these two terms before in other classes. So data is just information that's gathered. And so quantitative data involves number, like quantity. Qualitative involves something other than numbers. So qualitative data basically classifies or groups individuals into some sort of categories. Whereas quantitative data tells how much or many of something there are. In other words, the actual information you're gathering is a number. Okay, so let's do another quick example, kind of like we did for statistic or parameter. So I want you to tell me whether this is qualitative. I can't spell apparently. Oh well, there we go. I really can't spell. I'll get it. There we go. All right, qualitative or quantitative? So let's run through some different scenarios. So a person's age, a person's gender, the MPG of a car, and the color of a car. Okay. So if these were survey questions for someone to answer, what you need to do is not pay attention to how many of these could be counted, because frankly we could count any number of these things, but it really is the information being gathered. Is it a number or is it not? So the information being gathered in a person's age is a number, so it is quantitative. The information being gathered if you're requesting someone's gender is not quantitative, right? It would be male, female, okay, or whatever. So that would be qualitative data, okay? The MPG of a car, the information you'd be gathering would be some sort of number. Notice this would be a decimal and this probably wouldn't be a decimal, but that's okay. It's just whether it's a number or not. So this is quantitative, whereas a color of a car would be qualitative. Okay. Note that I could still count the number of black cars that I saw, right? So it's not a matter of can you count them, because you probably could count just about any of these items. Really the point is the data you're collecting a number or is it not a number? Okay. So notice the color and someone's gender, neither one of those are numbers. Okay, so data can either be qualitative or quantitative. Data can also be either ordinal, or we have a second option also. Okay, so ordinal is when you have a qualitative, notice that means non-number, qualitative quantity whose categories have a natural ordering. So notice the base word for ordinal is ordering. Okay, so we'll do an example of that in a minute. The other option is that the information could be nominal. So these are still qualitative variables, but the data doesn't have any sort of natural order. Okay. Note that this is always talking about non-numbered data to begin with, because numbered data would actually always be able to be ordered, so we really wouldn't ask that question about number data. So ordinal or nominal, flip over my words today. Honestly, that's the worst thing of whiteout I've ever had. So ordinal or nominal. So let's look at a few scenarios here. So let's say I want you to tell me the state you live in, state whether that is ordered or not. Gender. Letter grades in most college classes. So in case we need some guidance there, remember those are A, B, C, D, F. And then let's look at the size of fries you can order at McDonald's. So let's say you can order small, medium, and large. Okay. So notice all of these things, the state you live in, the gender, your letter grade, size of the fries, none of those things are numbers. So they are all qualitative data. Okay. So the question is, can you, with the responses you would get if you asked someone what state do you live in, could you order that, or does it have a natural order? And notice it doesn't, right? Even though everybody from Texas thinks their state is better than all the other states, there's no ranking as far as that goes, so that would just be nominal. It's just name only. There's no natural order. Same with gender. There's no natural order of the genders, right? None that are, quote, better or worse or higher or lower. But notice with the letter grade, the letter is associated with kind of a natural ordering, right? An A being the highest grade you can get, and then an F being the lowest grade you can get. So this would actually be ordinal. And same with the size of fries, right? Like there actually is a natural order, right? Small has the least amount of fries, while the large has the largest amount of fries. So there is some sort of order here, so we would say this is ordinal. Okay, okay, so that's kind of qualitative data in a nutshell. We can also split up quantitative data into two categories. So we're going to look at variables that are discrete, and then a second option as well. So discrete variables are quantitative. Notice that means number involved, right? So quantitative variables whose possible values can be listed, or at least there can be some sort of pattern for them to be listed. So I'm going to say this here. The list can be infinite. In other words, it can go on forever and ever as long as there would be some way for you to list them and kind of get a pattern going. And so that is the opposite of the other type of quantitative variable called a continuous variable. So continuous variables are again quantitative. They're number-based. But these values can take on any value in an interval. In other words, you wouldn't be able to get any sort of pattern going because you could always come up with something that wouldn't kind of fit the pattern. So a good way to think of this is variables that are continuous cannot be listed. Okay, so this one is a little bit tougher to see sometimes. So let's look at some number-based data and decide whether it's continuous or discrete. Okay, so let's say this is some data we're looking at. Your age, your height, the number of siblings you have, and let's say the distance of your commute to work. Okay, note all of these things would be numbers, right? If I asked you to give me a survey answer for any of these things, you would give me a number as an answer. So the question is, can you list out or begin to list out the ages for part A without kind of forgetting any ages, right? So you can, right? You can list any and all ages out, even though you might have to make your list quite long. It would be discrete, okay? But notice your height would be more of a challenge. Like people measure height in different ways, right? So I could be asking for your height in feet. I could be asking for your height in centimeters. I could be asking for your height in paper clips. I mean, nobody would do that, but I'm just saying there are lots of different ways to kind of measure height. So this is actually continuous. So this one, it could be a decimal or fraction. It could be different units, all kinds of things. In other words, you couldn't really list out someone's height. You'd always have to be squeezing something more specific in between. So what I mean by that is someone who's 5'8" standing next to someone who's 5'9", you could always have someone who is 5'8.5" in between them. Or you could always say like 5'8" plus 1/8 of an inch or something like that. So it's like you always can kind of think of one more value to squeeze in between two values, and that's what it means when it says it can't be listed. It's like there's always something else that could be sticking in between the two people, whereas your age isn't really like that, right? We generally talk about someone's age either in years or when they're an infant in months, but that's really all we talk about age in reference to. What about the number of siblings? I hope you could list out all your siblings, right? But that would be discrete, okay? And then the distance of your commute to work. Notice that this is kind of similar to your height. So this would be continuous also. In other words, you could talk about it being 30 miles, but you could also talk about it being kilometers, or you could talk about it being, 45 minutes away or something like that. So again, anything that generally can be a decimal or a fraction, and it's mainstream for it to be a decimal or a fraction, then it's probably not going to be discrete. It's going to be continuous. Okay. So again, you're going to have lots of opportunities to practice this if you'll just look at the homework and the quizzes. Okay, so keep that in mind. So if you want to, you can kind of pause this video as you're watching and taking notes and go answer questions based on these topics if you'd like to. All right, so now that we have kind of some statistical terms out of the way, we're going to look at some terms that we use when we design experiments. Okay, so there's different types of terms we need to look at when we discuss experiments. And by the way, experiments doesn't always mean like a white coat and, chemicals for chemistry class or something. It can just mean you're looking at a group of people and you're studying their income, or you're studying their heights or their weights or something like that. So that can be an experiment too. So the first term in this category is experimental units. That is a really fancy term for saying the individuals you're going to study. Again, don't make the assumption that that always means individual means people. It doesn't always mean people. It can be people, and often it is. But it could be animals, could be plants, could be things or items. So if you are working for a company, you might be measuring machine parts or something and coming up with what size manufacturing pieces you're coming up with. And so in that case, your experimental units might be the actual item you're taking measurements of. But when it is people that you are studying, you usually call them subjects. So when the item being studied is a human being, a person, we call it a subject. Okay. What you're often studying in an experiment is some sort of outcome or response. Okay. An outcome or response is what you're trying to measure. So if it's a survey question, it's the question you're asking and the answers that they give you. If you are performing a medical experiment, it might be people's vital signs when they take a certain drug compared to when they don't take a drug or something like that. So it can be lots of different things. So whatever it is that you're trying to study, the treatment is the procedure that is applied to the group being studied. So it's the procedures applied to each experimental unit. So in my medical example that I just gave, the treatment would be the giving of the medicine. Okay, that was supposed to help them or whatever. Know that they're in a well-defined experiment anyway, there will always be 2 or more treatments. You don't treat everybody the same. You don't give them the same if it's a medical experiment, you don't give them all the same medicine. Otherwise, what are you comparing them to? So the reason you have to have different types of treatment is because the purpose of your experiment to begin with is to see if your treatment made a difference, right? So it's to determine whether the choice of treatment changes the outcome or not. Okay, so one example of that in science class might be, I don't know if y'all ever did this when you were in junior high, but I'm pretty sure my kids did, but there's an experiment where you can test to see if different types of music make your plants grow at different rates. Okay, so the treatment would be the music they listen to or lack thereof, and the response you're trying to figure out is, you know, what's the growth of each plant comparatively? Do some music treatments result in better plant growth than others? So there are 2 categories of experiments. One is called a randomized experiment. Anytime you see a term with the term random in it, it means that every item is equally likely. Okay, things are kind of to chance, they're not being chosen or whatever. So this would be a study in which the investigator or the person running the procedure or the experiment, The investigator assigns the treatments to the experimental units at random. So in my plant example, it would be like these plants are going to listen to classical music, these plants are going to listen to heavy metal music, and these plants over here are going to listen to no music at all. And then we're going to compare and see if it makes a difference on how the plant grows or not. Okay, so that would be a randomized experiment where the researcher / the person running the experiment gets to decide who gets the treatment and who doesn't, and who gets which treatment on top of that. So that is not always feasible / ethical, and we're going to talk about what I mean by that in a minute. So the other type of experiment is an observational study, and just like the name implies, you just observe the data. You don't decide who goes into each group. You just kind of observe the groups as they are. So the difference is really who controls what groups the subjects are in, or the experimental units are in. Sorry, I had to figure out where I was. Okay, so the groups are not assigned by the investigator. Okay, so let's look at kind of a two-part on this one too. Notice that these terms are often in kind of pairs. Is it this or is it this? And that's how I would learn them when I'm trying to commit these to memory if I were in your shoes. So try to learn kind of pairs of terms and then move on to the next pair. All right, so let's look at two experiment setups. Okay, so in order for this to kind of be complete, I'm going to need to be a little more wordy on this. So let's say that 30 patients are given a new medication, and 30 patients are given a placebo. So a placebo in medical terms is just a sugar pill. It makes people think that they're taking the same pill as everybody else. And the reason you use this is because the psychological effects of someone knowing that they're getting treatment sometimes actually makes them better, and it's not the medicine themselves or the medicine itself. So 30 patients are given a new med, and then 30 patients are given a placebo, and they probably look alike, and no one really knows who has the real meds. No one knows who has the real medication versus the placebo, and then we can study the groups. So skip a line so that we can put an answer in there. So the second scenario is maybe you want to, don't know why you would, because there's lots of research out there that proves what the answer to this is, but does smoking cause cancer? And so let's say that 30 smokers and 30 non-smokers are compared. Okay, so notice in both experiments we're comparing 30 subjects to 30 subjects, right? The treatment here is the medication. The treatment here is whether or not they're a smoker or not. Okay, so the point that it is, the point for you to decide whether it's randomized or observational is, would it be possible / ethical to assign groups here? Notice here, you would probably be randomly picking which patients got the new meds and which patients got the sugar pill. So this would be a randomized experiment. In other words, even if you randomly drew names out of a hat for who was going to get the treatment, you'd have to have some that got it and some that didn't. Okay. So let's compare that to the situation in Part B. Notice it would be completely wrong and unethical of me to say, okay, I'm studying you 60 people. I need 30 of you to become smokers so I can study the effects and see if you get cancer or not. And then the other 30 of y'all aren't going to smoke. Okay. Notice we would never, ever, ever do that, right? Treatment would not be assigned in something like that. So, but we could go ahead and take 30 already established smokers, right? And I could just observe what happens with them, right? I could compare 30 people who admit that they smoke, okay, to 30 people who don't, and then see if cancer is more prominent in the people who smoke. So treatment cannot be assigned here, right? It would not be right to do so. So it's all in a matter of whether or not you can assign it or not. Treatment can't be assigned. You're either a smoker or you're not. So it's all kind of in the power that the investigator has, whether or not we would allow them to make those treatment decisions or not. Okay. So when you're trying to decide who gets the treatment or not, like in Part A, there is something called a blind experiment. But a double-blind experiment, a blind experiment is where the patients don't know who's getting the medication, which I think we can agree would be probably smart, right? You don't want to tell the patient who's getting the real drug and who's getting the sugar pill, okay? But a double-blind experiment is actually where no one knows. Like, the investigator doesn't know either. So, like, maybe he lets a computer system pick the ones that get the pill and the ones that don't. So I don't know if you've ever listened to those medical commercials where they're advertising for new types of medicines for things, but a lot of times I've heard them say in a double-blind study of blah, blah, blah number of people, and the reason they're saying it's double-blind is because that means that the researchers also didn't know what group the patients were in, because sometimes there can be some bias with some researchers. Okay. In other words, let's say that you are a researcher for a big drug company, and your income is going to depend on whether or not, your income is going to be dependent on whether this drug gets approved or not. You know, might you be tempted to kind of exaggerate how well the drug works if you knew you had $1 million bonus coming if it did get approved? So in this case, a double blind would kind of protect you from that, because you wouldn't really know actually who had been taking the pill versus who hadn't been. So a confounder is something that you always need to be aware of in an experiment. So this is a variable that is maybe unexpected and somehow related both to the treatment and the outcome. The important thing that I want you to know about a confounder is that it confuses results. Because basically there's something else going on that the investigator's not seeing. It is basically something other than the treatment that is causing the different outcomes. So you need to be aware of confounders, and you need to kind of avoid them if you can. Okay. So one example I've got of that is there's been studies that show that people that drink diet sodas are often more overweight than people who don't drink diet sodas. And so people who, don't like diet soda or don't like Splenda or whatever sweetener they're using will say, oh, that's because the diet soda is causing people to gain weight. Well, no. it's probably due to a secondary factor, right? Which is the fact that people who are already trying to manage their weight probably are more likely to choose diet soda than someone who's not trying to manage their weight, right? So it confounds or confuses the results because you're making assumptions that maybe you can't make. Okay, there's something else going on there that's changing your results, or that's affecting your results, I should say. So the problem with observational studies, although they are necessary for examples like the smoking one, for instance, they can often be problematic because of confounding. In other words, things that we weren't expecting to have an effect on our experiment can and happen more so with observational studies because we don't have a whole lot of control on how the experiment is run. All right, so let's look at a scenario. So let's say that a group of people in a city with high levels of pollution, so think like LA or something, are compared to a group of people in a more rural area, say Leonard, with low levels of air pollution. And let's say we want to discuss their lung capacity. In other words, how much air they're able to get into their lungs at any one time. So the first thing that I want you to answer is this a randomized experiment? Or an observational study? Okay. In other words, can treatment groups be assigned, or are they just kind of already what they are and you just kind of have to accept that? Okay. So we're trying to compare people that live in the city with high levels of pollution to people that live in the country with low levels of pollution, right? So notice that we can't decide who we're going to make live in the country and who we're going to make live in the city, right? So this is definitely an observational study. The investigator doesn't get to say, hey, you go live here and you go live here and then we'll study you, right? That's not a thing. So where a subject lives cannot be decided or cannot be assigned. Okay. So it is an observational study. In other words, we would probably just compare some families that already live in the city, right? We'd compare those with families that already live in the country, okay? So let's say if the city people have less lung capacity than the rural people, does this prove pollution is the cause? Okay, and so the key here is the fact that we're trying to prove something is true, kind of beyond a shadow of a doubt, right? So I would imagine that the city people probably do have less lung capacity than the rural people, but note that that still wouldn't prove that it was due to the pollution, right? So the lung capacity could be affected by many other factors, right? I mean, we don't even know what could be going on there, right? And those many other factors, or the situation that we can't really know for sure, is called confounding. Okay, in other words, there might be something that you're not thinking about that is actually the cause of the less lung capacity for the city dwellers. Okay. All right. So while we're talking about observational studies, just because they are actually pretty common, because they don't invade people's privacy as much as, assigning treatment groups to people. Okay, so two types of observational studies are, the first one is called cohort studies. So this is where a group of subjects or cohorts a group is studied to determine whether various factors of interest are associated with an outcome. So I've seen documentaries that will study a class full of kids or something, and they'll follow that class of kids up throughout the years. Okay, so they're taking a group of subjects at a time and they're kind of studying them all together. Okay, that's what a cohort study is. A case control study is where two samples from each group are drawn. One group with the characteristic you're trying to study and one group without. So to be fancier about it, one might have the characteristic of intent. That's the technical name for what you're studying. And so these would be called the cases, the ones that have the quality you're studying. And then one group without the characteristic, and those would be the controls. So in our smoking example, the characteristic we would be studying is whether they're a smoker or not, right? And kind of what effects that have. So the people that were in the smoking group would be the cases, and the people that were not the smokers, they would be the controls. Okay, so I'm going to kind of quickly go through. The last thing we're going to talk about is all studies or experiments have some bias. We need to be aware of that. It's impossible to eliminate bias, but we can try to reduce it when possible. So bias is the degree to which a procedure systematically either overestimates or underestimates a population value. So maybe we expect the numbers to be higher or lower or just somehow different than what they are. Okay. So the types of bias are as follows. The first one is called a voluntary response bias. We've mentioned voluntary responses before. And the bias with voluntary response scenarios is just what I said before. People with strong opinions are more likely to respond, so the survey will be biased towards those people, unless you know that that's the case, right? This whiteout pen is just giving me fits today. Another type of bias that you need to be aware of is a self-interest bias. You need to be aware of it yourself, but also be aware of, putting too much stock in experiments that have a self-interest bias. In other words, people that have an interest in the outcome will sometimes either intentionally or unintentionally mess with the results or just not give clear results. So I gave an example of the researcher that works for a drug company who stands to make a big bonus if the drug ends up being effective. So you have to be on the lookout for that.